Okay, in order to prove part one here, you need to be aware of two properties. First, this is a basic trigonometric cofunction identity. That comes into play later. But over here, from this graph on Desmos, if f of x is any continuous function from 0 and on, the definite integral from 0 to a of f of x dx is always equal to the definite integral from 0 to a of f of a minus x dx. And I'll send a link to this Desmos graph. You can change this f of x to any function you want that's continuous and change the a value using this slider, and you'll see you always get the same value. So these are equal. I'm not going to go into the proof. Board 2, here's a proof that I found on the with a Google search that does prove that property. You can take a look at that, but we'll assume you have that in your arsenal. So if that's true, then the definite integral from 0 to pi over 2 of f, where f is continuous, of cosine of x dx, whoops, this parentheses should have been here, is equal to, using this property right here, f of the cosine of pi over 2 minus x. That's this value right here in this identity. And the cosine of pi over 2 minus x is the sine of x using the cofunction. So we've proven part one. And now here's the cool part. Part two, if we let f of x be the continuous function x squared, then we could say I equals the definite integral from 0 to pi over 2 of f of the sine of x, which would be sine squared of x. But we know that that's the same as f of the cosine of x. So these two integrals are equal. And if I add them together, I get 2I equals the definite integral from 0 to pi over 2 of sine squared plus cosine squared. But sine squared plus cosine squared is always 1. The antiderivative of that is just x. Evaluated from 0 to pi over 2 is just pi over 2 minus 0, or pi over 2. If we divide by 2, I equals pi over 4. Okay, and that is the value of the definite integral from 0 to pi over 2 of sine squared of x or cosine squared of x. Okay, there you go. If you have any questions, post a comment.